work. I had to finagle with the USB reader in my PC a couple times. I don't know if it was because it was not used since it was created, but I think the adapter, the little USB adapter, I need to replace it. Once I was able to get it to work in my USB on my computer, I was then able to get the printer and whatnot to read the cards. So I'm printing a model called Shoe, and it looks like it's for 200 degrees Celsius for the print head or the end, and 60 degrees for the bed. So we'll see how it goes. Come on, there we go. So looks like it's sticking to the print bed, so I'm not sure if I'll have to adjust the Z-axis. It seems really good. And we'll have to see how it goes. See what this shoe looks like. You can see the remnants of the yellow test prints that they did. From all the videos I've seen of their manufacturing, they test print in yellow, and then they gave us white. So we'll have to see how that turns out. But so far, feels pretty good. Doesn't seem to be moving. I'm not able to remove it from the print bed, so we'll see. I will check back in later. So after taking the time to pull it apart off camera, I'll have to decide if I want to leave those bloopers in or not. So this is what it looks like pulled apart. And the clips that I was talking about, you can see the little rectangular holes. Those are grabbed by, let's see, where are they? They're hard to see, but there's little sort of standoffs that they clip onto. So looking at the top part of the extruder, or excuse me, the filament runout sensor, there's two little tubes that align the filament within the sensor. So these are really nice, but having said that, they also come out of place. And what you need to be aware of is these little brass tubes. Of course, that one's not going to come out now. These little brass tubes are flattened on one side. So you can see how it's flat on the top there. So that helps it align in the cover in a certain orientation. And that orientation involves this cutout on the other side. So you can see there's sort of an angle on that as well. And what that does is it allows these two brass tubes to fit alongside the bearing and the roller. So there's the least amount of places, or there's not enough space for the filament to slip out of the path, the intended path. So it'll sit, of course this is one side, it'll sit up against the bearing like that, and it'll push it directly in between those two rollers and the bearing, or the bearing and the roller. And then the shorter one will sit on the, where's my hand? Sit on the other side, so it literally has nowhere to go except in those two tubes, which is a nice, I don't want to say addition, but it's a nice thought that they did to make sure that there were no issues. So the other side of it here you can see is the actual sensor part of it. And that clicking noise you hear when you put the filament in is actually this little plastic part. Let's see if I can get a good shot of it. Oh, and of course the spring just shot out. Where is it? There it is. Okay, so we'll deal with that later. But when the filament comes through here, it pushes this roller down. You can see on the right hand side, it forces the leg, so to speak, to unbreak the line of sight for the optical sensor. So when there's filament in there, it'll sit like right about there. And you can see those two little tiny notches. If my camera will decide to focus right there. So you can see the two notches right here and right here. And then when the filament runs out, that spring will force this leg or arm to break that optical sensor. And then it says, hey, the filament is out because I can no longer see the other side of my optical sensor. So the clicking noise is just this mechanical part moving up and down as the filament is forced through it when you first insert it, but it's actually a optical sensor that's being used. So it's using this arm or leg here, depending on how you want to look at it, to break that sensor. Now, going back to what I mentioned where some people were saying that the runout sensor wasn't always working, and my theory is that it's because this little board is not secured in the case. So I really have to work on my single-handed videotaping skills. So you can see that it sits on these two standoffs, but it could become loose, which would change the tolerance or the, it would change the way that this leg would fit in that sensor range. So what I may end up doing is either taking a soldering iron and melting those legs so that they're sort of flat, so they're more like rivets, I guess you could say. Or I may just break out my wife's craft hot glue gun and just put a little dab there and a little dab there so that it doesn't move anymore. Because when I first opened this, it actually was loose. It had come free of those standoffs and was causing it to wobble around. So if you do have runout sensor issues, I would recommend maybe trying to make that a little bit more solid, either by melting the plastic so it's like a rivet, or putting 2 small dabs of hot glue on there so that it doesn't move anymore. Because I can definitely see that as being a problem. Then of course you just have your regular standard bearing. And then on here is just a little brass wheel that allows the filament to pass through the bearing on one side and this roller on the other. And it's cheap. I won't say it's cheaply made, but you can tell it's cheap because it's just plastic. If they really wanted to prevent issues with this, they would have put a little bit more work into it and maybe made a little bit more metal type of parts in here. But again, you're only holding in a small circuit board and a bearing, so it's not like it's not gonna go through a whole lot of work or a whole lot of rough usage. Beyond that, the rest of the gantry is as it was when we went through it the first time. You have your dual Z lead screws, you have your 2 motors down here, and then that's basically it for the major components that I can think of. Feel free to put comments in if you saw something I didn't quite go over. I can go a little bit more in depth in sort of a follow-up video. Be sure to share, like, and subscribe. That way people can see that the CR-6 is actually getting out there. People are interested, people are looking at it, and we'll see how what the future holds for the CR-6. After this, I'm going to actually go into the assembly. They're going to go over all of the parts that come with it. I have not forgotten about the secret drawer, so we're going to go over that as well. And then we're going to get it all together, up and running, and started printing, because I'm really anxious. It's been 2 or 3 days now, and I haven't done anything as far as printing, so we'll see you then. So this is sort of, I wouldn't consider it an outtake, but I'm going to try to demonstrate how the filament sensor works in relation to the optical part of it. And it's always nice to see how things work internally versus trying to see how they work with the cover on. So you can see here that the filament will go in on this side. Let's see if I can get a good view of this. And then it'll fit in the groove of the bearing, and then it sort of pushes that roller down, and you can see where the mechanical sound comes from, but it's not actually mechanical, as we went over a few minutes ago. And once it goes through, you can see that it would go through those two brass tubes so that it wouldn't sort of curl up on the inside of the device. It'll actually go straight through. And I can probably demonstrate that. So the first tube will go here, and there's not much holding it in on this side of the case. Let's see if I can get in there. Sort of, not really. It's not going to work for me. But you can see, so one side of it will literally almost butt up against the bearing, and then you push it through, and then it'll immediately go into the shorter section of the tubing, so that there's no issues with putting the filament through. So I think that would be better demonstrated maybe this way. I think my first purchase is going to be a camera mount so that I have both hands free and it looks better. But you put the tube in, it actually will hit the bearing, separate that roller from the bearing, and then it'll actually force it through the other side. And of course that won't pop out because it'll forced together by the screws, but the casing held together. But you can see that there's very little area for the filament to actually lose its way